Hello class, welcome back to another section of my 4 intensive multivariable course. We are still on vector functions. In this class, we're going to consider derivatives of vector functions, integral of vector functions, and some examples here. We've talked about vector functions in our previous videos. We found the domain, then also the limits. Now, in this class, as you proceed, we find the derivatives as well as the integral. From our knowledge in calculus 2, we know that we can find simple derivatives and also simple definite and indefinite integrals. So let's employ the same thing here. So as I gave you, a vector function is simply a vector with function as its component. So if I give you a function like 2x, comma, sine 2t, let's say sine 2x rather, comma, e to the power x, then I ask you to differentiate. You simply differentiate each component. So meaning our derivative will also be a function. So let's try this. We're going to have derivative of 2x to be 2. Derivative of this is simply going to be what? 2 cos 2t. And the derivative of this remains e to the power x. And this is simply the derivative of vector functions. Let's solve the example I have here. I have r of t to be equal to t to the power 6 I plus sine 2t j minus ln of t plus 1 k. So if I have this vector function here and I've been asked to find r prime of t, what do? I simply differentiate each component of this function. When I do this, I'm going to get 6t to the power 5i plus, this is going to give me 2 cos 2t j. Then here is the ln function. You know that to differentiate a ln, you have to differentiate its argument over its argument. Therefore, if I differentiate this, I'm going to get 1. So minus 1 over t plus 1k. And this gives me my derivative, as simple like that. Let's go to the integral of vector functions, and this also holds. If I consider my test function here and I want to integrate, I'm going to have 2x back again, sine 2x, then e to the power x. If I am to integrate this, I will integrate each component. Hence, this will give me what? S squared, comma, this will give me 1 over 2, negative 1 over 2 cos 2x. Then this will give me e to the power x, and that is exactly my integral. It can be definite. This is indefinite. So it can be definite. Now for the indefinite, you add plus c to it. Now for the definite, you make sure that you apply the endpoint to each component. So let's see an example here. I'm going to have r to be equal to r of t to be equal to the angle sine t 6 then 4t. I've been asked to find integral from 0 to 1 of my r of t, and this is simply going to give me, here will give me negative cos t. You put your 0 1 here, comma, this will give me, when you integrate 6 you get 6t. You put your 0 1 here, comma, you get 2t squared. I'll put my 0 1 here. So once I get this, I'll simply apply my endpoints. So if I put 1 here, I'm going to get cos 1. And if I put 0, I'm going to get cos 0. So what is cos 1? So cos 1 is simply going to be what? 1. So let's see. Cos 1 is going to be, so negative open brackets cos 1 minus cos 0. Then also this part is going to give me 6 open brackets 1 minus, I'm putting 0 there, 0. Then comma 2 open brackets 1 squared minus 0 squared. I close it back again. Now negative. So I'm going to have cos 1 is 0.99. So let me make it 0.99. 99, then cos 0 is 1, comma, this is going to be equal to 6, then this is going to be 1 squared here, so we get 2 back again. Now let's just leave it in cos and our answer will be fine. So let me make it, here it's going to be cos negative 1, so let me maintain the cos 1. I'm going to get negative cos 1 then plus 1 like this, comma 6 then 2, and this becomes our definite integral. This is simply how we go about with vector functions. If this is your first time visiting the channel, don't forget to like, subscribe and share. Thanks for watching this video.